Welcome. In this particular video, we'll be looking at function notation with exponential functions part 4. Let's take a look at our first example. Example 1. Given f of x is equal to 5/2 to the x, find f of negative 3. Well, here we know that our input value happens to be negative 3. So what we're going to do is to substitute in the negative 3 wherever we see an x. So f of negative 3 is equal to 5/2 to the negative third power. Now here, whenever you see a fraction raised to a negative exponent, what that means is that we're going to have to take the reciprocal of the fraction and we're going to get the opposite of the exponent to get an equivalent expression. So by using that fact, we can say that f of negative 3 is equal to the reciprocal of 5/2, which is 2/5, raised to the opposite of negative 3, which is 3. Now here, using repeated multiplication, we can rewrite f of negative 3 as follows. F of negative 3 is equal to 2/5 times 2/5 times 2/5. So multiplying across, we get that f of negative 3 is equal to 2 times 2 is 4, times 2 gives you 8. And then 5 times 5 is 25, times 5 is 125. So we get that f of negative 3 is equal to 8 over 125. Let's see a couple more examples. Example 2. Given g of x is equal to 1/4 to the x, find g of negative 2. Once again, here our input value happens to be negative 2. So let's go ahead and substitute that into the original definition of the function. So we have g of negative 2 is equal to 1/4 to the negative 2 power. Now, using the fact that whenever you have the base to a negative exponent, you're going to get the reciprocal of the base and the opposite of the exponent. To rewrite the equivalent statement, we can say that g of negative 2 is equal to the reciprocal 1/4, which happens to be 4, over 1, and the opposite of negative 2, which happens to be 2. Now, 4 over 1 is simply 4. So we have that g of negative 2 is just 4 to the second power here. And 4 to the second power means that you have g of 2 equals to 4 times 4, which is 16. So we can conclude that g of negative 2 is equal to 16 in here. So let's see one last example here. Example 3. Given h of x is equal to 2/5 to the x, find h of negative 3. Notice that your input value is negative 3. So we have that h of negative 3 is equal to 2/5 raised to the negative third power. Now, rewriting this using the fact that we can get the reciprocal of the base and the opposite of the exponent, we get that h of negative 3 is equal to the reciprocal of 2/5, which is 5/2, raised to the opposite of negative 3, which is 3. Now, once again, using repeated multiplication, we get that h of negative 3 is equal to 5/2 times 5/2 times 5/2. Now, multiplying across, we get that h of negative 3 is equal to 5 times 5 gives you 25, times 5 is 125, all over 2 times 2, which is 4, times 2, which is 8. So we can say that h of negative 3 is equal to 125 over 8. So whenever you see any exponential expression raised to a negative exponent, what you do is you simply take the reciprocal of the base and the opposite of the exponent to get an equivalent statement. So that's it for today. Thank you for watching and have a wonderful day.